Lesson. Formulas. The biggest mystery of math. Millions of years passed. Millions of theorems derived. Millions of formulas made. But still, x is unknown. A formula is a mathematical relationship or rule expressed in symbols. An equality relating one mathematical expression to another. An identity. A transformation of a sum or term into a product, or vice versa. 1. The binomial square formula. A plus b, everything squared. The binomial square expands into a trinomial. So this is equal to a squared, which is the first term squared, plus 2ab, add twice the product of the two terms, plus b squared. Add the second term squared. The formula is used to perform calculations. Let's compare and contrast the two sides of the identity. The degree of the left side is 2, and the degree of each term on the right side is also 2. The left side has 2 terms inside of the parentheses, and the right side has 3 terms. The left side is a power product, while the right side is a sum. The left side of the formula is shorter than the right side of the formula. The exponent of the binomial is 2. The right side has 3 terms, one more than the exponent of the binomial. The coefficients of the first and last term in this expansion are 1. The coefficient of the middle term is 2, the same as the power. This is a sum squared. The power does not distribute to the terms like it would, as we see here on the right side, in a product squared. This is the product squared, and the power distributes to each factor. Important. If the coefficients of a and b have the same sign, then all terms have positive coefficients. If the coefficients of a and b have different signs, then only the coefficient of twice the product is negative. Another thing to keep in mind is to square a product, you square each factor. Example. The quantity negative 4x to the negative 4 raised to the power 2 is equal to 16 times x raised to the power negative 8. To square a sum, you square each term and also add twice their product. A plus b, everything raised to the second power, equals a squared plus b squared is not an identity. An example. The quantity 5x to the fifth power plus 3y cubed, everything squared. The binomial square expands into a product by squaring the first term, 5x to the power 5, everything squared, and then adding twice the product of the two terms, 2 times 5x to the fifth times 3y to the third, and then adding the second term squared, plus 3y cubed, everything squared. Performing calculations, we obtain 25x to the 10th, plus 30x to the 5th, y to the 3rd, plus 9y to the 6th. The binomial square formula also allows us to compress a trinomial into a binomial square. So the formula is used to factor a trinomial. The other way around, it expands a binomial square into a trinomial. The formula is used in that case to perform calculations. So for example, we have 16x to the fourth plus 24x squared y to the third plus 9y to the sixth. The first term is a perfect square, so 4x squared raised to the second power. And the third is a perfect square too. 3y to the third, everything raised to the second power. The middle term is twice the product of the first two terms. So plus 2 times 4x squared times 3y cubed. The trinomial compresses into a binomial square. So a here is represented by 4x squared. And b is 3y cubed. So we have the binomial square 4x squared plus 3y to the third, everything squared. Next, we have the trinomial square formula, which pertains to a plus b plus c, everything squared, which in this case equals a squared, the first term squared, plus b squared, the second term squared, plus c squared, which is the third term squared, plus 2ab, which is twice the product of the first two terms, plus 2ac, which is twice the product of the first and third term, plus 2bc, which is twice the product of the second and third terms. The coefficient of the perfect squares are 1, and the coefficients of twice the products are 2, the same as the power. There are 3 terms inside the parentheses. Their power is equal to 2. 3 times 2 is 6, which is the same as the number of terms on the right side. So what the trinomial square formula does from the left-hand side to the right-hand side is expand the trinomial square into a sextic polynomial. The formula is used to perform calculations. Now, when we reverse the order of the two sides and we have it the other way around, it is used to compress a sextist polynomial into a trinomial square. The formula is used to factor a polynomial. The degree of the left side is 2, and the degree of each term on the right side is also 2. The left side is a power product, and the right side is a sum. The left side is shorter than the right side, and the trinomial square expands into a sum. So for example, we have 2x plus 3y minus 5, everything squared. The first term squared is 4x squared, plus the second term squared plus 9y squared, plus the third term squared, which is positive 25. Add twice the product of the first two terms, 2x and 3y, so we have 2 times 2 times 3, 12xy. Then we add twice the product of the first and third terms, 2 times 2 times negative 5, which results in negative 20x. And then we have twice the product of the second and third terms. So 2 times 3 times negative 5, which is negative 30y. Now let's see an example of how we compress. 16x to the fourth minus 16x to the third plus 28x squared minus 12x plus 9. In order to compress the polynomial into a trinomial square, you must have 3 perfect squares and 6 terms. The first term is a perfect square, and the last term is also a perfect square. The coefficient of the middle term is not a perfect square. It can be written as the sum of a perfect square and another term. The other term must have an even coefficient because it represents twice the product of two terms. Thus, the perfect square also must have an even coefficient because the sum of two even numbers is even. So 28x squared can be broken down into 4x squared plus 24x squared. Or 16x squared plus 12x squared. Let's try the first probability and see how it works out. So we have 2x everything squared plus 24x squared. We must check whether the other three terms represent twice the products of AB, AC, and BC respectively. Let's write the polynomial as 4x squared everything raised to the second power plus 2x raised to the second power plus 2 times 4x squared times 3, which is that 24x squared from before, plus 3 squared minus 2 times 4x squared times 2x, which comes from that 16x cubed, minus 2 times 2x times 3. So in this case, A is our 4x squared, B is our negative 2x, and C is 3. To AC is represented as 2 times 4x squared times 3. To AB is seen to be represented as 2 times 4x squared times negative 2x. And to BC is represented by 2 times negative 2x times 3. Thus, we can compress the polynomial into a trinomial square. The quantity 4x squared minus 2x plus 3, everything squared. 3. The binomial cube formula. A plus b, everything cubed, equals a cubed plus 3a squared b plus 3ab squared plus b cubed. The coefficients of the two cubes are 1, and the coefficients of the two middle terms are 3, the same as the power of the binomial. The right side has 4 terms, which is 1 more than the power of the binomial. The binomial cube expands into a quadrinomial. And this quadrinomial compresses back into a binomial cube. The degree of the left side is 3, and the degree of each term on the right side has a degree of 3 as well. The left side is shorter than the right side. Example: P of x equals the quantity 2x plus 5 everything cubed minus 140x minus 125. What is the sum of the coefficients of the polynomial p written in standard form? So let's perform calculations. Expand the binomial cube into a quadrinomial. So a cubed, 2x everything cubed, plus 3 times a squared, 2x squared, times b, 5, plus 3 times a, 2x, times b squared, 5 squared, plus b cubed, 5 cubed, minus 140x minus 125. Those come directly from the question statement. So performing calculations, we have 8x cubed plus 3 times 4x squared times 5 plus 3x times 2x times 25 plus 125 minus 140x minus 125. So we continue to perform calculations. 8x cubed plus 60x squared plus 150x plus 125 minus 140x minus 125. So now we can begin grouping like terms and performing calculations on them. 8x cubed plus 60x squared plus 10x, because we have 150x, negative 140x. And then the 125s cancel out, leaving us our final answer of 8x cubed plus 60x squared plus 10x. The sum of the coefficients of the polynomial p is 8 plus 60 plus 10, which equals 78, leaving us with the correct answer of D. Now we have another example where the polynomial is defined as 27 times the quantity negative 2x cubed plus 4x squared times the quantity x cubed minus x squared plus the quantity negative 2x cubed plus 4x squared times the quantity 9x minus 1. All right, so the prime factorization of this polynomial p over the set of integers is p of x equals ax to the power u plus bx plus c to the power v times dx plus e to the power w, where a is less than 0. So what is the sum of all of these coefficients? So the first thing we're going to do is place the GCF, which is the quantity negative 2x cubed plus 4x squared, into the front. And to factor GCF, that means to divide each term by the GCF. So dividing the first term by the GCF, we obtain 27 times the quantity x cubed minus x squared. And dividing the second term by the GCF leaves us with the quantity 9x minus 1. So then we place the GCF of the first parentheses, which is negative 2x squared, in the front. So this is equal to negative 2x squared divided by the first term. So the negative 2's cancel out. We have x cubed divided by x squared. Subtract the exponents, keep the base. 3 minus 2 is 1, x. Same thing with the second term. 4 divided by negative 2 is negative 2. X squared divided by x squared is 1. So negative 2 is the second term. Now inside the bracket, we'll begin eliminating parentheses and applying the distributive property of multiplication over addition. So that leaves us with 27x cubed minus 27x squared plus 9x minus 1. This quadrinomial that we're left with might compress as a binomial cube because it has two perfect cubes rather evidently inside of it. So let's write the quadrinomial, if possible, as a cubed plus 3a squared b plus 3ab squared plus b cubed. This results in 27x cubed being written as 3x everything cubed plus 3 times the quantity 3x everything squared times negative 1 plus 3 times 3x times the quantity negative 1 squared plus negative 1 cubed. So indeed, this quadrinomial compresses as a binomial cube. That specific binomial cube being 3x minus 1 everything cubed. From this, we can see that a is equal to negative 2, b is equal to 1, c is equal to negative 2, d is equal to 3, e is equal to negative 1, u is equal to 2, v is equal to 1, and w is equal to 3. So summing all of those up, some quick maths allows us to eliminate the 2's, eliminate the 1's, and with the remaining terms left, they sum to 5, which means our answer is E, none of the above. 4. Difference of cubes formula. A cubed minus b cubed is equal to a minus b. We've removed the cubes and kept the negative sign, times the quantity a squared plus ab plus b squared. The left side is a difference. The right side is a product. And the difference of cubes expands into a special product. The first factor is linear, and the second factor is quadratic. The right side has degree 3. The left side has degree 3 as well. And an example, true or false? 8x minus 1 everything cubed, negative 27x negative 5 everything cubed. The sum of the two factors of the polynomial above is equal to 97x squared negative 224x plus 255. So let's see. The polynomial above has two terms, not two factors. The polynomial must be factored. Expand the difference of cubes into a special product. So, in this case, a is represented by 8x minus 1, and b is represented by 3 times the quantity x minus 5. So we have a minus b times a squared, which is 8x minus 1, everything squared, plus ab, which is 3 times 8x minus 1 times the quantity x minus 5, plus b squared, which is 3 times the quantity x minus 5, everything squared, which results in 9 times the quantity x minus 5 squared. Eliminating parentheses inside the bracket results in 8x minus 1 minus 3x plus 15. And then we can expand the binomial squares inside our second bracket into trinomials and perform additional calculations. So the first term squared is 64x squared minus twice the product of the two terms. So we have negative 16x. And then the second term squared is 1. Now in our second term, we're going to multiply the two binomials, obtaining 3 times the quantity 8x squared minus 40x minus x, which we can combine right there. We see they're easy to combine. That's negative 41x plus 5, the product of negative 1 and negative 5. And then we continue on and expand the final term. 9 times the quantity of the first term squared, x squared. Then twice the product of the two terms, x times negative 5 times 2, resulting in negative 10, plus the second term squared, which is 25. Then we can group and add like terms. The quantity 5x plus 14. And then in our larger bracket, we need to apply the distributive property of multiplication over addition. So 64x squared minus 16x plus 1 plus 24x squared, 3 times 8x squared, minus 123x, 3 times negative 41x, plus 15, 3 times 5, plus 9x squared, minus 90x, plus 225. So let's group and add like terms now that we've really performed as many calculations as we could to break up our parentheses. So everything with the x squared. 64x squared plus 24x squared plus 9x squared is 97x squared. Then we have negative 16x, negative 123x, negative 90x, negative 229x. Then we have 1, 15, and 225, plus 241. This then results in the prime factorization of the polynomial over the set of integers. The sum of these two factors is then 97x squared minus 229x plus 241 plus 5x plus 14. That evaluates to 97x squared minus 224x plus 255. Thus, the statement is true. A special product compresses into a difference of cubes. 5. The sum of cubes formula. A cubed plus b cubed. Remove the cubes and keep the positive sign. So we have the quantity a plus b times the quantity a squared minus ab plus b squared. The sum of cubes expands into a special product. The left side is a sum, while the right side is a product. The first factor is linear, and the second factor is quadratic. The degree of the right side is 3, and the degree of the left side is also 3. The left side is shorter than the right side. For example, always, sometimes, or never. The prime factorization of a sum of cubes over the set of integers has two factors. There must be a proof for all statements that are always true or never true. If there are two examples, one for which the statement is true and another one for which the statement is false, then the statement is sometimes true. Example, x to the third plus 8 equals x plus 2 times the quantity x squared minus x plus 4. This is an example of a prime factorization of a sum of cubes that has two factors. What about 8x cubed plus 8, which equals 8 times the quantity x cubed plus 1, which equals 8 times the quantity 8x plus 1 times the quantity x squared minus x plus 1. This is an example of a prime factorization of a sum of cubes that has more than two factors. Thus, our statement is sometimes true. Now, when we look at the sum of cubes formula in another light, we can see that a special product compresses into the sum of cubes. The formula is used to perform calculations one way. True or false? the quantity x squared minus 9 times the quantity x squared minus 3x plus 9 times the quantity x squared plus 3x plus 9 equals x to the 6th minus 729. So the left side of the equality is a product and the right side is a difference. To prove or disprove the equality, we either have to perform calculations on the left side of the equality or factor the binomial on the right side. Let's work with it on the left side. So expanding the difference of squares into a special product, x squared minus 9 is equal to x minus 3 times x plus 3 times x squared minus 3x plus 9 times x squared plus 3x plus 9. Multiplication is commutative and associative. Thus, we can multiply the first and fourth factors. The special product that we've selected compresses into the difference of cubes. So those two are equal to x cubed minus 27. Now, if we look at the product of the second and third factor, we also notice that this compresses into sum of cubes. X cubed plus 27. And this special product compresses into the difference of squares, thus equaling x to the 6th minus 729. Thus, the statement is true. Mixed applications. True or false? The quantity negative 5x cubed plus 10x cubed negative 5x, everything raised to the third power, equals negative 5x times the quantity x minus 1 times the quantity x plus 1, everything raised to the 6th power, for all x belonging to the set of real numbers. The left side of the equality is a power, while the right side of the equality is a product. Factor the GCF of negative 5x of the trinomial inside the parentheses. Place the GCF negative 5x in front of the trinomial, and to factor this GCF, it means to divide each term of the trinomial by the GCF. So, negative 5x to the power 5 divided by negative 5x results in x to the 4th because the negative 5's cancel out, and x to the 5th divided by x is x to the 5th minus 1, or x to the 4th. Similarly, 10 times x to the 3rd divided by negative 5x equals negative 2x squared. And negative 5x divided by itself, negative 5x, is positive 1. The entire expression cubed. And now let's continue performing calculations. Negative 5x raised to the third power is negative 125x cubed times the quantity x to the 4th minus 2x squared plus 1, everything cubed, which equals negative 125x cubed times the quantity x squared minus 1, everything raised to the second power, everything raised to the third power. So we compressed that trinomial into a binomial squared. Now, when continuing to perform calculations, we obtain negative 125x cubed times the quantity x squared minus 1, everything raised to the 6th power. This in turn is equal to negative 125x cubed times the quantity x minus 1 times the quantity x plus 1, everything raised to the 6th power. Difference of squares expanded. Then distribute the power, obtaining negative 125x cubed times the quantity x minus 1, everything to the 6th, times the quantity x plus 1, everything to the 6th. These two expressions are not equal. Thus, our answer to the question is false. Always, sometimes, or never. The quantity x cubed negative 9x squared positive 27x negative 27 everything squared is equal to the quantity x squared negative 6x positive 9 everything cubed. So the left side here of the equality is a power, and the right side of the equality is also a power. The exponents are different though, 2 and 3 respectively, so what can we do from here? This is equivalent to x cubed minus 3 times x squared times 3. We've rewritten 9x squared plus 3 times x times 3 cubed. We've rewritten 27x. You see what we're getting at here? We're working the quantity in here to be more tractable. Minus 3 cubed, 27. Everything squared. Which equals x squared negative 2 times x times 3 plus 3 squared, everything raised to the power 3. This is equivalent to the quantity x minus 3, everything raised to the third power, everything raised to the power 2, which is equal to x minus 3, everything raised to the second power, everything raised to the third. Equivalent to x minus 3 raised to the sixth equals x minus 3, everything raised to the sixth. Thus, this statement is always true. The end.